Hello, everyone. Welcome to this month's Professor Messer Network Plus Study Group. This is the month of April 2012 already, and we are doing our normal monthly study group for Network Plus. This is just something I like to do every month. I take your questions that you send me, and I create some content around it, and we sit around for an hour. If you are watching this live, we welcome you. Thank you for attending. We've got people in chat rooms. I'm watching a chat room that we have going on Ustream. I've got another chat room that I've got set up specifically for this on the Professor Messer website at the bottom. And if you're watching this after the fact, because we are recording all of this, we're posting it up on YouTube. There are links on the Professor Messer website and on Twitter and on Facebook and all of that. And I generally get those up by the end of the day, beginning of the next, somewhere in there, so that we can watch this. And if you go to the freenetworkplus.com link, which takes you to the Professor Messer website, at the bottom of the Network Plus videos are replays of every other study group that we have done. There's some really, really good content in there. So if you are planning to take your exam, you might want to flip through those and scan through those and see the different topics, especially near the end where we talk about some study tips you can do for taking your Network Plus exam. There's some great things there as well. Well, what I wanted to do is sort of jump into things. I've got quite a lot of content that we've got ready for this month. This month, just so you're aware, something that I'm able to do because of your support. The website is something that does have a business. It's a revenue. It has to bring in money to be able to live. And fortunately, all of you have been really great about supporting those things. The Network Plus course is one that you can watch every single video online. You can see all the content absolutely free, and I will always provide all of that content absolutely free online. I think it's a fantastic resource. Some of you have wanted to take those videos with you, though, when you're not on the net, or maybe you've wanted MP3 versions, or maybe you just wanted something in HD. I had somebody send me an email a few weeks ago saying he just plugged it into his PlayStation and just played the MP4 files right there in 720p high definition right there on his television. And I thought that was a great idea on how to do it. And I will send you those DVD-ROMs so that you can do exactly the same thing. If you wanted to see more about that and help support the site, you can find it at professormesser.com/download-net+. Well, there's quite a bit that we're going to go through this week. For those of you that are relatively new to Network Plus, there are 2 Network Plus certifications you can take right now. So you got an option. You got to figure out which one you want to take. There is an N10005 that was released in December. That is the newest version. And so you'll hear me talk about the 005 and the 004 versions going back and forth. The 005 is brand new. I am still working on completing all the videos for that because it is brand new. So you can see a lot of those on the Professor Messer website. There's a link at the top that will take you to the 004 or the 005. You can take both of these right now. You can sign up for either one and walk in and take it. So there's a little bit of time until August the 31st of this year. And if you're watching this in a replay, think about what time it is, because in August 31st of 2012, the 004 goes away forever, and you would have to, at that point, take the 005. Now, the important thing to remember is that this 004 and 005 that's here both get you the Network Plus certification. There is no difference in those two things. So when you get your certification, it says you passed Network Plus. Doesn't say you passed Network Plus 004. Doesn't say you passed Network Plus 005. You simply are Network Plus certified. So take the one that makes sense for you. If you've been studying the 004 for 6 months, go ahead and finish taking the 004. It doesn't make any sense for you to stop what you were doing and reset and try to learn all the new things that were in the 005 pieces of those things. So just something to keep in mind as you're working through these ideas of what you're going to need to know, where you're going to be able to find those things. That's pretty important for those different pieces. If you have your certifications, maybe you have an A+ certification, a Network Plus certification, and you'd like to keep that certification up to date, this particular presentation allows that as well. If you go out to CompTIA's website, you can see that you have certification credits that you can gain, continuing education units, and you can get up to 4 CEUs if you have an A+, or up to 6 for the Network Plus just by attending this, and you send that documentation into CompTIA to be able to say, yes, I did this. So just another thing that makes it nice. If you're watching, there's another benefit that's associated with that. Well, let's jump into, by the way, to answer Ed's question in the chat room, is there anything covered in 004 that isn't covered in 005 and that's still readily used? Not really readily used. I would say everything in 005 is still pretty right on with the most modern of things. A lot of the really, really, really old stuff usually gets dropped off. A lot of the newest things usually are added. And then if you go to the top of the freenetworkplus.com page, or you just go to the top of the 005 video page on Professor Messer, I have an excerpt right at the top of the page that goes through a previous study group where we talked about in detail what are the differences between the 004 and the 005. So there wasn't a lot of new content, because Sean is asking in the chat room, between 004 and 005, but there was a number of new things. So it's important to know what is different. The virtualization pieces, a lot of new security pieces in the Network Plus. So some very significant additions in the Network Plus certification. Make sure you look at those. And we'll talk more about that as we go through this particular study group today, about things you can do to help understand what's new and what's not in that newest version of the exam. The questions I get come from you all month long. You send me via email when you signed up for the study group. You had an option to put in there what question would you like to have covered on the study group. I get all of these. So I have this huge spreadsheet of questions that I go through. A lot of the questions are duplicated. I try to pull those out. If somebody asks a very unique question, then I like to put those in here too. So that's very useful. Somebody said in the chat room, do I provide proof of attendance? I don't have a way to prove you were here. So I don't think CompTIA cares too much about that. So don't worry so much about that piece as attending. So I appreciate your questions that you sent in. They help make this study group better, and it's fantastic to get all of those. One of the questions I always get interesting questions from you. You never fail to send me in thought-provoking and interesting questions. And the question I got this week that I thought from Jerry asked, well, Jerry, that's a very good question. How would? And I thought, how can I think about how would? How can I answer the how would? Well, I'm going to leave this up to you. So the thing that I'm going to let you do is help me answer this question. And for those of you, if you're watching this, pop out a new window or pop open a new browser and have that off to the side, because we're going to answer this question in these interactive Q&As that I like to do. And we're going to do a few of these in the study group. This one, if you go to pollev.com/Messer, or you simply text the code that's associated with your answer to 37607, or you can even tweet to @poll with the code you want. The question of how would, you can answer okay, well, very, or which I think are pretty good questions to have. I think those are pretty good responses to how would. How would? Okay. How would? Well. How would? Very. How would? What's nice about this, obviously, this is just a sample to get you understanding how this process works so that you can vote on these. But one of the nice parts about this is that we're able to see the results in real time as you're sending them in. So for most of you, how would? Well. Some of you, how would? So a good mix. So it's nice. We're able to really get interactive views of exactly what's going on inside of this. So it's kind of fun to be able to sit through these pieces and understand how to do that. And I have a number of questions I will be asking of you in the study group today. So this will be some great learning opportunities. I have some great Q&As. I'm going to ask you questions you probably shouldn't know, and some of you might know. So some really, really good things in here. Is indeed the dark horse candidate, Ryan, in the chat room. I think that's the good. So most of you, how would? You would well, I guess. So I hope, Jerry, that has helped answer your question on how would. Now let's ask a real question. Let's go through some of the things that I want to know about. And this would kind of start things going today. I think it's going to help me understand better some of the things I need to know about what we're doing. The question I have for you, now that you know how this works, is how long have you been studying for the Network Plus exam? I'm interested in knowing, have you been studying for less than a month? Have you been studying from 1 to 3 months, 3 to 6 months, or more than 6 months? And that's going to help me as we go through this particular view. As we go through this study group today, it'll help me understand more about what you are doing or how you are studying or how long you've been studying for these different exams. And what I found pretty interesting about this, the part that I like about this is there's a good mix. Some of you, and I think the vast majority, if we go back to some of the A+ study groups that we've done in the past, almost all of these have been in really the first 3 months or so. And you can see some of you have been doing this for a while. You've been trying for the last 6 months, trying to learn this information. The Network Plus information is very varied and different, which are both the same thing. So you're going to find that sometimes it takes a while to really understand the details. Some people study in part-time. They're not students. They aren't doing this full-time. So I get an interesting mix of exactly what's going on with some of these pieces. So you can see a good chunk of us are well distributed between 1 month, 1 to 3, and 3 to 6. And then there's a 16% of the people said more than 6 months in here. So some very interesting views of that. So I will absolutely make sure as we go through some of these topics today that if you've been studying for, 62% of us have been studying for just 3 months now, or less than 3 months, I'll make sure that we go through those topics in detail to be able to understand the pieces of those as we step through them. So let's go to the questions that you asked this week. Let's go through all of the things. One of the ones that I first got, and I think it was a great question because it's not covered incredibly well in a lot of the things that we see online, is what really is a VLAN? What really is a virtual LAN? CS asked this. And I thought this would be a good thing to go through. Now, we go through this in the Network Plus study materials. It's in the videos. But if you ever worked with VLANs before, or if you've never worked with VLANs before, it is a concept that can be difficult to really understand, to really grasp. So I wanted to draw a few more pictures, something you wouldn't necessarily have in the videos that we have today. If you've ever seen this picture that I have in what I've been working with, let me move this here. So you've seen this picture before in the videos that I have, where if we just looked at sort of the old days of doing things, let's take these switches that have no VLAN capabilities, or even hubs if you want to go back into the old days where we really had dinosaurs roaming the network. You would have different departments that were all centralized within each other. And that's because all of your printers, your servers, your materials that are there are all focused on things specific to you. So the red department has everybody's plugged into the same hub or the same switch. The green department is all plugged into the same hub and the same switch. And usually these departments are all sitting in the same place in the building. So it makes it very easy to do that. And you can also have these blue, this is the blue department. They're all plugged into their same old hub and their same old switch. Well, the problem, of course, these days is nobody's in the same building. Everybody's in different floors of the building. They're all over the place. You can't physically plug everybody into the same connection. And so what we do is use VLANs, and we separate out these. Now we put smarter switches in place, and we tell these smarter switches, if you're plugging into this port, you're on the green network. If you're plugging into this port, you're on the red network. And that means we can separate people all over the environment. And I'm just separating people by department, but these VLANs can be organized in any way you'd like. And so now you've got red people that are plugging in different places. The green people can be distributed geographically. The blue people, they're somewhere else as well. And you have these things called trunks that connect the switches together. And those trunks take all of those different types of VLANs and combine them into one wire. Because it would be crazy. What if we ended up unplugging and plugging? We had to have a separate cable for every VLAN between switches. That wouldn't even make sense. So what we do is just create this single trunk, we call it, that takes every VLAN, and we're able to communicate every VLAN through that trunk. If we wanted to see this a different way, this is how I would view this a different way. Let's look at the switch that's in the rack that we're looking at. So these VLANs that we would assign now would be assigned in the configuration of the switch. They're software assigned. So we would set up some ports on the switch would be for the blue network. Some ports on the switch, we would go into the switch and configure and say, I'd like these particular ports to be for the green network. And then I would go into the switch and configure some other ports to maybe be for the red network. And I got some other ports left over. So I would plug in the appropriate people to the appropriate ports, and now they'd be plug in. Now let's say on the other side of the campus, I have another switch. And I have that department. Those people are on the other side of the campus plugged into the switch. The person who's administering this particular switch, not as organized as the person who was administering the first switch. So I want you to know you can make any port go anywhere on any VLAN is the point I'm making with this. Your blue people might be scattered in there. There might be some green folks. There might be some red folks intermixed with that. It's up to you how you configure your switch and where you put people in which VLAN. Now we have the problem that we need to now have the red people talk to the red people and the green people talk to the green people and the blue people talk to the blue people. So what we do is we build a trunk. We put one connection, and you can see on this switch, there are these extra ports off to the side that are specifically designed for uplinks. And they have both copper connections in there. You can gig Ethernet copper. And they've also got this slot that you can use for an SFP. This SFP is this pluggable type modular connector. I wish I had a SFP with me. I have a GBIC with me. I have an show and tell time. I have an SFP. I told you I'd have one. This is all live. Don't you like live goods? This is an SFP, a small form factor pluggable. And this SFP has a little interface in the back. You can kind of see the interface that plugs into the back of the switch. And on the front of the SFP, we get up to the camera. How's this for having this very nice? So in the front of the SFP is where your fiber connector plugs in. You can even see the fiber interface that's right in there. If my camera will zoom up on it, it won't. The focus is trying very hard to not focus properly. But that's the size of them. There's just tiny little interface that you plug in. And this particular switch has one of those interfaces on it. So if you wanted to use fiber, you can plug that in and you plug in your fiber and you connect these. Or if you're close enough together, you can use copper. Copper is generally less expensive. So we would use copper. I think I hurt my arm kind of reaching over there. So what we'll do is we'll do the same thing. We will connect a wire between those two, a copper connection between those two. Now, what we haven't told the switches, of course, is that we need the reds and the greens and the blues to talk to each other. So you configure your switch and say, this is going to be a trunk connection. And in this trunk connection, I want to allow all of those different VLANs to talk back and forth. So you have complete control over this and being able to use it that way. That is the way that we would set up VLANs in a production environment across multiple switches and connect this trunk connection between them to be able to send that traffic back and forth. So very, very useful to have that functionality. And it allows us to put people in many different places. They can be wherever we want to have them. So instead of corralling people into one section of the building, there can be plenty of room. Anybody can go wherever they'd like, and you can administratively put them exactly where they need to be. Each one of those colors is a subnet. So each one of these, the blues and the greens and the reds, would all communicate to each other with the same subnet communication. So very, very useful to have that piece and have it available there. So it's a very, very nice to have that. So I have a question for you about VLANs. Now, this particular question is not one you really need to know for the Network Plus exam, but I thought it would be good to at least give you some insight into some things that you can do with that. So let me give you a feel for this question. This question is about VLAN. So we created a trunk, and that trunk had 3 different VLANs inside of it. But what is the maximum number of VLANs that can exist within a single trunk? How many VLANs could you squeeze into a trunk and send information back and forth? That's a really good question to be able to do this. Now, as I mentioned, probably a little off the scope of the Network Plus exam, but I thought it'd be interesting to at least get an idea of what's there. And I'm not going to show the results until we have a good chunk in. I don't want people going either way with this. Now, it's interesting in this trunking technology that you just have to keep everything straight. I've gone into production environments in data centers of enormous companies, and we have plugged into devices, and I plugged in a workstation, I plugged in an IP addressable device, and we can't talk to that device. And I'll ask the person, what VLAN are we on? Are we on the right VLAN? They'll go, absolutely, we're on the right VLAN. He's in the right VLAN. And so I'll ping out. I'll try to ping my local gateway. I can't get to my local gateway. If you can't ping if you can ping yourself and you can't ping anything else, especially your local gateway on your subnet, that tells you that there's some problem there communicating off to that gateway. And that's the problem we went through, was it wasn't on the right VLAN. We had to go back and look at the VLAN configuration, get it all done, and see, oh no, that's VLAN 7. You should be on VLAN 14. Let me change that. Click, click, click. Now I can ping my local gateway. Very, very common to see that. So let's look at the results of this particular one so far. A good mix. So I did not expect anyone to know the answer to this. And I see a lot of you said, well, let's just try it. Let's just guess at what it could be. The correct answer, interestingly enough, is 4,094 different VLANs can be squeezed inside or configured inside of a single trunk. Now, the way this actually works is we don't really squeeze anything. You know, there's not really tiny little lines that are paths inside of that wire. What we do is take the data that's going through and we tag it. And by tagging it, we say this data, when it gets to the other side, this data is on VLAN 7. Gets to the other side, the other switch sees it and goes, oh, VLAN 7, let me break the tag off and put it on VLAN 7. And then we want to send the other one. We'll send it on, we'll tag it with VLAN 14. It goes to the other side. The other side pulls the tag off and says, okay, VLAN 14, there you go. Very, very easy to see that there and find those little pieces that are there. So you can do a lot with this. In some environments, this is completely off the scope of Network Plus, but if you worked in a provider, a network provider type of environment where you weren't just in a corporate environment, you were providing network services for thousands of customers, they do things like double tagging so that you can have even more VLANs inside of VLANs. Whoa, that's crazy. That's way off the scope of what we're doing. But you can see the VLAN technology, very, very useful, something you can run into and use quite a bit. So let's now look at some other pieces on here. One of the things, or questions I get quite a bit, deals with command lines. And one of the things that when I'm working at the command line, and I just mentioned a very good example of this, I like to be able to have certain tools available for troubleshooting. And when I start working at the command line is where I really start running into a number of challenges, because which command line function do you use and when? So behind the scenes here, I'm going to set up for us a command line view that we can work with here. And I want to be sure it's one that I can really show you, because the question that came through, and this particular question is one that came from Wendy. And Wendy's question to us was, what commands such as ping are most commonly used for troubleshooting? And as you know, for things like the Network Plus exam, we're very focused on Windows type troubleshooting to be able to do those pieces. So I wanted to give you a feel for commands you can use at a Windows command prompt, just a couple to help you troubleshoot and do different things. In the chat room, you're already saying, yep, let's try these. Let's try these. Let's do exactly those. Let's do some pings. Let's do some trace routes, some IPconfigs and things like that. The one that I'm going to work with, we'll go through this. We're going to do a ping so we can figure out, can we see someone else on the network? Let's also look at running trace routes to know where some of these problems may be occurring. And I'd also like maybe to give you a feel for what it takes to do a packet capture, because that can be incredibly useful, a little bit outside the scope of Network Plus. But if you're planning to do anything on the network, boy, your packet captures are going to be incredibly valuable to be able to do that. So let's see how that might work. Let's do a couple of things. I'm going to see if I can stop my presentation here and flip over to a VM, and I'm going to kind of get this on the screen so we can really see what's going on with that. I think that's a pretty good view, and hopefully we'll be able to work with that if I use the right keyboard. Is that going to view that okay? It is. Let's see if it's going to keep up with what I'm doing. This zoomed view is not one that works very well. So I'll keep adjusting my screen. You won't exactly see me in real time when I'm using this. So if you're using Windows, we want to be able to see what the configuration is of our workstation. So you use a command called IPconfig. Whenever you're working with Windows or Linux or any operating system, the first thing you should know is, what am I doing right now? What is the current status of where I am on this network? In the Linux world, it's an if config, interface config, if config. So you don't have to worry about that piece so much. But you do have to think about exactly what pieces are going through there. So let's have a look at some of those and get a feel for some of the things we can do. We can see my IP address is 10.1.10.52. Looks like I've got a subnet mask of 255.255.255.0. I've got a default gateway of 10.1.10.1. So if I'm looking at this and I'm trying to determine, can I even communicate to other people on my subnet, your default gateway is going to be a very good one to be able to do that with. I think it's very useful to be able to know that. So let's do a ping to 10.1.10.1. And the command to do that is ping 10.1, 10.1. It's a very, very simple command to be able to make that happen. And if we hit that, you can see kind of interactively as I move my screen around here, there's the results of that. So I know that when we are working here and being able to do these things, we are really able to talk directly to our gateway. So it's not just me. I know I can talk to the gateway. I know I can get a response back. So very nice to be able to do that. Now let's get a feel for other things. Let's see if we can talk out to Google. And a very good example of this is to ping Google's DNS service. I love using this because it's a number I can remember. And for those of you that have done it before, you ping 8.8.8.8. I can remember 8.8.8.8. That's very, very useful to be able to do that. So if you ping 8.8.8.8, I can absolutely talk to Google. Whew, okay. I know I can at least communicate out to the internet and back. So these types of things help me understand exactly what's going on in my environment. Now let's take an idea and let's say that we're concerned that we're not able to communicate out to Google. Let's say we couldn't ping 8.8.8.8, but I could ping other things on the internet. I might want to see where along the line I was not able to connect any further. Maybe the problem isn't here locally. I can talk to my gateway, but somewhere out there on the internet, we aren't able to talk very far. So let's do that. Let's do a trace route. And the command is trace RT in Windows. And if we simply do a trace route to 8.8.8.8, we're now going to step through every link along the way and get a feel for how far can we get through these connections as we're stepping through each connection. And sometimes you'll find a router that will not reply back to you because it does not allow this type of communication through it. But most routers will for this very reason, because the administrators of the routers are also using these to be able to communicate. So you can keep going back and forth and back and forth and back and forth and see just how far it takes to get to Google. And in places where you can do a DNS lookup of the name, you can see the DNS names associated with it and where it goes. And based on the names, I can even kind of tell where it's going. I know that it started here in Tallahassee. It went to Marietta, Georgia. So it went up to Atlanta. That's out there in the northern part of the Atlanta area. And then it went to some IP addresses that don't have DNS names associated with them, and then finally got to Google. So I know all the way through this the exact path it takes to go from point A to point B. That's very valuable to have that information there. Another nice part about this is anytime now that I lose a connection, if I can't get to a remote site, I can run a trace route. This will tell me just how far it gets before it fails. If you're administering a corporate environment, you've got a wide area network, and for some reason you can't communicate out to the site that's in Poughkeepsie, you can do a trace route to Poughkeepsie and see where along the lines did it fail. And now you can go to your service provider. You can find out the last router that should have been there and its status. Sometimes you have to drive into a data center or call somebody, but now you know. And I know exactly what's going on with those pieces. Very useful to be able to run the trace route and see those pieces there. And one of the things that they asked in the chat room, is it true sometimes you'll get a timeout, but the connection is indeed working? Absolutely. Because you'll sometimes see along these links, you'll see it go through its test. It does 3 tests and then it goes to the next one and it never gets a response because traceroute uses a number of different things to communicate, but the one it uses by default, the protocol it uses by default is ICMP. And not all routers will respond to an ICMP request. And when that happens, we don't get a response, we don't get a response, we don't get a response. So now let's go to the next one. And you'll just see a bunch of asterisks show up there instead of the timers that are there. So don't worry that you weren't able to see that. That router just was not able to tell you anything. It was not able to participate in the trace route, but obviously communication is going through it because you were able to get to the other side of the trace route. Now, if you never get to the other side of the trace route, you may have a problem right there on that router. So not all connections will allow you to trace route, but when you can, You can get some really good feedback from exactly what is there. And if you are planning to do anything with troubleshooting a network, with trying to find different ways to determine exactly what's going on your network, those are incredibly useful commands to be able to use right there at the command line and be able to get a feel for exactly what's there. Now, I mentioned earlier, another thing that can be very, very useful is to get packet captures. And if you do not have Wireshark loaded on your computer, you should absolutely go out to wireshark.org and do that. You should go out and get the world's most popular network protocol analyzer for just your own knowledge of what's going across the network. If you understand more about the packets that are going back and forth, and you can go out to the network and just start capturing data and understanding what's going right there, that can be really, really valuable to watch the things that are going on. Now, obviously, I have huge amounts of streaming data going on my network right now, and you're seeing a lot of this here. One nice thing about Wireshark is it gives you a summary of what traffic is going over your network, and then it provides you with amazing amounts of detail of the type of traffic going over your network, the size of frames. We can start to see exactly the type of the MAC addresses that were used to communicate back and forth. We can see the IP information and the flags that are inside of it and the IP addresses that were used to communicate. Just a ton of information here. Now, that is well outside the scope of Network Plus. You don't need to know down to the packet level to understand what you need for Network Plus. But if you really are getting into networking and you want to know ultimately how to troubleshoot a network, these protocol decodes and packet traces will be incredibly valuable for you. So that's something you can think about when using these pieces, is that's an amazing functionality to have available to you, but just don't think that you need that for your Network Plus. You don't necessarily have to have that, but boy, it will help you not just for Network Plus, but for well into the future when you're doing other things with these network technologies. Yeah, it's surprising just how much information you can get from a protocol decode. And I think about this, I correlate it back to a nurse who's reading an EKG, and it's of your heart, and you can see all of the little things that are happening on the strip of paper. I have no idea what that is, but a nurse can look at that and go, wow, you've got a mitral valve prolapse. I see exactly where your problem is with your heart. And they can see it from this strip of paper that's coming off of this, or on a screen that they're seeing live as it's going by. One of the interesting parts about the protocol decode is exactly the same thing. I can see the heartbeat. I can see exactly the way the application flows, and I can point and say, there's your problem with the application and why you're seeing the slowdown or why it's not working. Very, very valuable to have that. Just another one of those things that would become incredibly useful as you go through your networking career. So the command line pieces we looked at, and being able to understand exactly what's going on at the protocol decode level, I promise you will come back to you in spades as you go throughout your IT career. Incredibly valuable to have that information. Okay. There is a most requested topic that I get every month. Does anybody in the chat room care to guess what the most requested topic is in that I get from my emails, that I get from my registrations, that I get for, and here you go. Everybody's saying subnetting, 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 subnetting. And so let's have a subnetting question, shall we? I think we should. All of you asked me about subnetting. Now, one thing to keep in mind, and we'll talk about subnetting in this piece, is that it's just simple math. So don't be thrown by the fact that there's a subnet question on your exam. Generally, they can even be done in your head. And if you don't believe me, I will show you one in just a bit. Let's do a question, shall we? First, before we go into the questions, for those of you that have never had a subnetting question before, let me show you just how easy binary math is. Because when you're doing subnetting, you're really doing mathematics, but it's really at the binary level. If you type and write down just 8 zeros on your screen, 0, 0, 0, 0, 0, 0, 0, and you put on top of them, start on the right side, put a number 1, and then double it, which would be 2, and then double it, which would be 4, and then double it, which would be 8, and double it, 16, double again, 32, double again, 64, double again, 128. That is, at the most basic level, everything you need to know to be able to do subnetting and mathematics associated with subnetting. We can go a little bit further with this. If you kept going, you'd even be able to go farther out. But just keep in mind that these bits that we are using are simply zeros or ones, and we're going to use them in our calculations. When we put 8 of these bits together, at least in the PC world, we call that a byte. And sometimes we call it an octet. You'll see it referred to as 2 different names. An octet means that it's an 8-bit byte, just the word oct. And the octet is associated with that. Some computing systems have bytes that aren't 8 bits. We don't really see this much anymore, but a lot of the older mainframe systems had that. So whenever you see the word octet, that is somebody who's written a technical RFC, for instance, and they want to be very clear that we're talking about an 8-bit byte. So that's why you see octet occasionally. And that's your binary to decimal conversion chart. Just write that down. That will help you immensely when you start doing that on here. So let's also start counting some of those bits that are on here. Is we just took all 8 of those and we put ones on there, and we just stick our binary conversion part right on the top. We can start calculating bits and bytes associated with that. But I mentioned that we could keep going if we wanted to. We could just put more ones out to the side. Let's put 10 ones there. Just keep doubling your numbers every time. So you're going up to 256, you're going up to 512. Just keep doubling the numbers and doubling the numbers and doubling the numbers. You'll be fine with that piece. So that's the basics of setting up your conversion chart. Now let's start to use your conversion chart in a question. So we're going to use the subnet mask that is here. Our question is that we have this IP network address, 172.31.77.1, and I have a subnet mask of 23. Now, the question is, how many subnets can I get from this subnetting, and how many hosts per subnet can I get from this? That's a pretty good question to try to figure out some of these pieces. Now, we're going to look at this particular subnet, go down the line, but one of the things we'll do is we'll just break it out one at a time. The first thing you'll want to do is you want to write out in binary what this particular IP address is and the subnet mask. We have a subnet mask that is 23 bits long. That's what the /23 means. So if we were to write it out, you can see right here, if we write it out, it's 11111, there's 8, there's 16, and 23. And the rest of them will be zeros. So if you do the calculations of this and you add up all of those columns of numbers, that equals 255. You add up all of those columns of numbers, 255. You add all of these columns of numbers, you get 254. And that goes back to that conversion chart we created. If you were to add up, all of those are ones, and you add up 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, you get 255. So anytime you see a 1, add up the number that's above that. If you saw a 0 there, you wouldn't add the number. You would leave it blank because 0 means absolutely nothing in that scheme of things. So if we go back and look at that calculation that we did, it all lays out very nicely. 172.31.77.1, if we do the calculations in binary, you can see those calculations laid out right there. Now we broke out the pieces for the subnet mask. We knew we had 23 bits on a subnet mask, so we wrote out 23 ones, and we filled the rest with 0. So anything that is in the mask is the network, and anything that is outside of the mask that is the zeros is the hosts. So that's your separation between those two. Your subnet mask helps you understand what the subnet is and what the hosts are. And I put these little N's for the network and the H's for the hosts, just so you're able to see during the calculation piece exactly the pieces that are in here. And I realize I'm going through this quite rapidly, but I also want you to understand that you can rewind this. It's a video. So feel free to go through this. And we also have many, many videos in the Network Plus training that go through this as we go through these pieces. Just remember that our mask is going to put N's in there for our network, and our hosts are going to be the H's. And we had 9 bits left over, these 9 zeros on the hosts. So if I wanted to add up all 9 of those to be able to know what are these 9 zeros together, if we were to calculate using our binary table and figure out how many we could put in there, we added up every single one of those columns, we would get 510 possible hosts. I just clicked a few extra ones. Let's go back and look at that. I think that is one of the easiest things you can do, is figure out the mask. That is one of those that when you start working with it, very, very simple. I've got 9 bits there. Let's calculate the 9 bits, 512 possible clients. Now, if we calculate it, it's actually 512. If we look at we get 0 to 511, that's 512. But you don't use the first address because the first address is your subnet. You don't use the last address because the last address is your broadcast. So you use everything in between. So you take the number and you subtract 2. That's how we got the 510 out of it, not 512. So the calculation of how many possible clients was a pretty easy one, 510. Now let's go another step then. Let's figure out the subnet address. For the subnet address, you take everything that was your subnet address, all zeros, broadcast address, all ones. So for subnetting, we would take and do what we call a bitwise AND. We figure out for our subnet every time there is a 1 in the IP address and there is a 1 in the subnet mask, it's a 1. That the answer is 1. If there is a 0 and a 1, the answer is 0. And if there's a 0 and a 0, the answer is 0. So again, it's simple math. You're figuring out, is it a 1 or a 0? But it's a lot of writing. You have to write all of this out to do the calculations. I recognize that. And if we did the entire calculation with this bitwise AND, we would come up and have this number right here. And at that point, that's our subnet. All we have to do now is convert it back into decimal. And the conversion, if you went through and did your conversion table and you calculated it, 10101100 is 172, 0001111 is 31, 01001100 is 76, and all zeros obviously is 0. That's your subnet address. That was pretty easy. We just kept our subnet all zeros and we were able to get the subnet address. Now to get the broadcast address, it's exactly the same process. Instead of putting all zeros there, you put all ones in for the host and you do exactly the same calculation on it. And you get 172.31.77.255. There you go. That's it. You're just calculating these ones and zeros every time. So our subnet is 172.31.76.0 through 172.31.77.255. So let's summarize that. Your IP address 172.31.77.1 with a subnet mask of 255.255.254.0. Our subnet address 76.0, we knew that. Our broadcast address 172.31.77.255. The number of hosts on the network would be 510, which is 512 minus 2, and there's our address range for us. Well, that's a lot of calculations to get to that last number, isn't it? We're doing a lot to get to that final number. And I realize this. And one thing you should keep in mind for your Network Plus exam is you may get no subnetting questions. The subnetting section of Network Plus is a tiny little section within a much larger domain that's a member of many, many other domains of the exam. So don't kill yourself spending days trying to memorize the nuances of doing everything manually with your subnet calculations for 2 reasons. First, there may only be 1 or 2 questions on your exam about subnetting, and if you know the basics, you'll probably do pretty well. And secondly, in the real world, we use calculators. We use subnet calculators to do this, to double check ourselves. That's one of the things that's pretty nice about being able to go through these pieces. But it's not as hard as doing this. And let me show you why. Let's do a question here. So here's a question. This is a pretty good one you might get on your Network Plus exam. How many bits are in the subnet mask 255.255.128.0? So if you're interested in doing classless interdomain routing, this is it. This is not a class-based. This is 255.255.128.0. Do not put this in the chat, but you should absolutely answer this if you go to pollev.com/messer. You can answer this question, which is how many bits are in that subnet mask? Give you a second, let you answer some of these. Now remember, 255s are easy. That's 8 of them. So now I'm giving you some hints. So we know 255. That's another 8. How many bits does it take to make a 128 in binary? You can go back and look at your chart. Very easy to calculate 128. So what you do is you add up all of those bits and you should have the answer for the subnet mask. Is it 8, 9, 16, 17, 24, or 25? That's it. This is one of those times where you should be able to look at the question and you should be able to answer this one in your head. And if you start doing a lot of subnetting, you'll start to go, oh yeah, I can calculate that out pretty well. If you can't calculate this one out in your head quite yet, that's okay. You will. Once you do a number of other subnetting questions, this type of question should be one that you will get very, very accustomed to seeing. You'll be able to visualize it in your mind. You'll be able to calculate it very, very easily and put it in here. We've got 18 responses so far. Let's see how we've done. And the vast majority of you have said 17. There's a few people said 9, some said 16, some said 17, some said 24. Nobody said 25, nobody said 8 on the extremes. So let's see what the answer really is. So if we look at this particular question, we have 255 that's 8 bits, all ones. 255 is 8 bits, all ones. 128, if we were to look at our chart, 128 is 1 bit, 10000000. That makes it very easy to calculate. So we take the 8 plus 8 is 16 plus the 1 is 17. Everybody who answered /17, half of you, absolutely correct. There you go. So most of you, I recognize, have only been studying for the Network Plus exam less than 3 months. And for 60% of you to only have been studying for less than 3 months and having half of you get this question right, that's pretty good. You guys are doing great. You're on the right track. If you've never done subnetting before, that's a heck of a question. You're almost lost in the pieces of that. And that's okay too. You'll get this piece later. And hopefully that question has helped you and you can do some more subnetting with those pieces in there. But I think that's a really good example of the type of question you should be able to do in your head. You should be able to look at a subnet mask and know how many bits is in that subnet mask. Sometimes it's easy to memorize. Sometimes it's easy just to calculate out just the way we did just then. So keep working on that piece. And don't kill yourself over subnetting. If I had to tell you one thing, don't make subnetting such a big, enormous problem for the things that you're doing. It's not worth killing yourself over the details of doing the subnet masks, I assure you. So let's here's the things we just talked about. If you wanted to look at in detail of how we came up with that, we take our conversion chart. And there is the exact answer for those of you watching the video. That's exactly how we did it right there. And we counted up the total numbers to come up with that 17 bits. Ta-da. So if you're ever trying to figure this out, draw it out yourself. That's a really great way to go through those pieces. The next question we have, this came from Sean, and it asked, what are the differences between unicast, broadcast, and multicast? Because you see these all the time. You see, I've got unicast traffic. I've got broadcast traffic. There's multicast traffic. What is the difference between all of these? Why would I want to know? Why would I be concerned about all of these different communications types? I plug in the computer, it talks. Isn't that all you need to know? But there are some interesting nuances between these. Let's first talk about unicast. And let's talk about why you would use a unicast. This is one of these things where this is primarily what we do day to day. Most of the communication that your computer is doing is a unicast communication. Most of the traffic your machine is receiving is a unicast communication. This is one station sending information to another station. You're talking to a web server. The web server is talking to you. You're talking to an FTP server. The FTP server is talking to you. You're talking to Netflix. Netflix is talking to you. That is this unicast. These two devices might be sending private information between two systems. They might be doing the web browsing. They might be doing the file transfers. The problem you might have with unicast, and I just gave an example of this, is something like Netflix. With Netflix, you're asking to view a movie, and Netflix is sending you the movie. This isn't a scenario where you're simply on a television where you're tuning in at a particular time. Netflix is completely on demand. And so if for streaming media, can you imagine the infrastructure that is required to be able to send that much traffic on a unicast? Everybody gets their own private stream of data. Now, interestingly enough, Netflix is a company that is completely software as a service. All of the networking piece for Netflix is all run on the Amazon cloud. They use Amazon to communicate that. So it's really Amazon that has to send all these streams out to everybody. Netflix simply pays Amazon a fee for being able to do that, just as an aside. Some interesting stories there, but that. So what about broadcasts? Wouldn't it be easier just to send broadcasts and everybody would receive the broadcast? One of the challenges, of course, is that we're sending now to everybody at once. Whether you wanted to receive this or not, you're going to receive a broadcast. There's no way to opt out of a broadcast. You are getting broadcasts going through. One station sends out one packet. Every single person on the network sees that packet and it must receive it. Their network card is designed to grab the data and provide it to the operating system. The operating system has to look at it. So that's why broadcast storms become a little bit of a challenge. It has a limited scope, fortunately. You can't just send a broadcast out and broadcast it to everybody on the internet. That would be bad. And that's one of the reasons we have subnets, is so we can separate out broadcast domains. Subnets are effectively broadcast domains. If I send out a broadcast, only the people on my subnet will see that particular broadcast. Becomes very, very useful. So of course, I'm going to send routing updates. I'm going to send these address resolution protocol requests and responses, or requests certainly will go out via a broadcast. And I'll say, hey, is anybody out there 10.1.10.1? If you are, please send me your MAC address so I can talk to you. That's an ARP request. And that goes out via broadcast because we have no idea where that station is. So it has to be broadcast to everybody. That's a normal part of doing networking. Very, very useful to be able to have that capability to send those broadcasts, because routing updates need to go to everybody. ARP requests have to go to everybody. There's no way around it. But there is a middle ground, something called a multicast. What if I could send out a special frame called a multicast frame, and that multicast frame only was sent and received to the people interested in receiving it? That makes sense. This is like watching a television, turning to a particular channel. You're seeing the thing sent just to that channel. You see this all the time in things like multimedia delivery, especially localized on a single campus. So you would start a stream of traffic out, and that stream is sent to only the people whose machines subscribe to receive that stream. That's a little different than what we're doing right now. For those of you that are watching live, we're watching on Ustream. That's all unicast. Even though you're watching a stream, it's all being fed to you on a separate stream. Every single person gets a separate stream to be able to do that. A little bit of a challenge to make that happen. This is also done in stock exchanges. If you've ever seen those tickers of information that go across, tickers are often sent in a multicast. People that are doing transactions with stock exchanges send out, the stock exchange sends out the transaction. Somebody would like to buy stock, and they send it out via multicast. Now, multicast is sent to all the brokerages. Goes out all the brokerages all at once. Ideally, all the brokerages get that all at the same time, and then they process it. Oh, somebody wants to buy something? I have that stock. I'll sell that stock. They send in the sell request, and that sell request is sent directly back. It's not sent via multicast. It's sent unicast back to the stock exchange. The first one that gets back wins. They get the commission. As you can imagine, the networks that are involved for stock exchange brokerages have to be as fast as possible, because if you can get the multicast first, you can process the order first, you can send back the unicast first, you win, and you get the money. You get the commission on the sale. And that's why even with brokerages, you'll see some brokerage organizations run everything on fiber. They put the brokers on the first ports of a network switch, because certain network switches, the way the backplane of the switch works, those first ports would get the frames first. We're talking nanoseconds of an advance. And the faster you can be, the faster you'll be of your competition. They use multicast to be able to receive those requests. It's pretty interesting. So it's very specialized. You don't see this everywhere. You rarely see multicast. Only specialized applications are going to use multicast type environments. So you will not see that everywhere you go. Most of the time you'll see unicasts. The second most is certainly broadcast, and for specialized applications, you're going to see these multicasts come through. So let's look and see. We already asked a question then associated with the things that we have going on our network. Let's look at our next question here. We look at the broadcast and the unicast and the multicasts. What type of communication would be used by an IRC chat? We're chatting on IRC in this video right now. So what communication? Would it be unicast? Would it be broadcast? Would it be multicast? Would it be supercast? I think super. My cast is super, so it must be supercast. But you should answer what you think at pollev.com/Messer and put your results into the poll for your unicast, your broadcast, or your multicast. In a way, I kind of gave that one away a bit, didn't I? Because I told you how did for different applications work, although I didn't specifically talk about IRC, did I? IRC, you'd have to think about, how does IRC work? How does that communication happen? And then you can extrapolate from that what the type of communication would be to be able to send that IRC communication. Let's look at our results for this, and you can see 65% of you said, oh, it's multicast. IRC app must be, because there's tons of people looking at IRC, therefore it must be a multicast communication. Nope, it's not. But wait, that's a perfect way to use multicast. I could subscribe, and then everybody gets the multicast stream. That's exactly, no, it's not how it works, though. That would make sense that that's how it would work. The challenge you have, though, especially on the internet, is that all of the devices have to be aware of multicast. In this particular case, you would have to have the IRC server send out one packet that would magically get forwarded to everybody who is subscribed to that stream. But that's not how IRC works. With IRC, you log on to a central server, and that server sends the information back to you. If two people are on the server, both people log in, that IRC has to send duplicate information down to the server. There are 91 people in our chat right now. 91 of exactly the same piece of traffic has to go out to everybody in IRC. And if that seems like that doesn't make sense because it's horribly inefficient, then you're right. It doesn't make sense because it's horribly inefficient. You were absolutely right to think, gosh, multicast would make perfect sense. And it would, if we could be assured that multicast communication would work successfully through all parts of the internet, and we can't. So the vast majority of applications that you will see will be unicast. The second most amount of traffic you'll see on your network will be broadcast, unless you are running a very specialized piece of software that uses multicast to communicate. And that's a little bit more complex, a little bit more complicated, usually done on a campus environment or done with specialized apps like the stock brokerage one that I gave earlier. So there you go. Now you've learned something today. The only way to learn something is when you don't know, or you get it wrong, or you're trying to fix it. If you're troubleshooting something, you're learning something. So it's always good to be able to see, yes, okay, IRC, something like a unicast. That's the answer for IRC. I also want to tell you about freestyle. This study group that we do every month is absolutely free to everybody. It's because of the sponsorship of the great folks at GTS Learning. I've met with these guys in person. I've talked to them about the things that they're doing. They showed me this freestyle idea months ago, and I said, you've got to create this. This is the best thing ever. Because one of the main questions I get from you is, I need a book, I need videos, I need test questions. Well, I have videos, but I don't have a book. The folks at GTS Learning have books and they have questions. So I thought if we could combine some things together and put it in one place and integrate it together, then you'd have something. That's exactly what they've done. This is freestyle. I don't think I'm still logged in. Let me refresh this page, and I'll zoom in so you can see this a little bit better. Here's freestyle integrated learning. I'm going to log in with my login up here because I have the Network Plus course right here. They've given me this Network Plus view onto the side. This course has in it exactly the book material that GTS Learning sells. It's in freestyle. All of my videos are integrated in freestyle. All of the tests, sample tests, tests at the end of every chapter, they're all in here. And you can take all of these pieces right here in freestyle. Here's the course outline for the N10005. There's even a practice exam right at the top. So if you wanted to take a practice exam with a quiz and just step through this visual piece, yeah, start the attempt. We're going to try it out and let you see this piece. Not going to go all the way through it, certainly, because there's 100 questions. But here is, you have a web server, blah, blah, blah. Do I do this? You know, some detailed questions on here. You can navigate through the quiz with the questions on the left side. And at the end of it, you'll get a response for what you got right and what you got wrong. Even more importantly, as you step through these quizzes and these sample tests, you'll get feedback about where you can learn about that particular topic. So unlike the real exam where you have no idea what you got right or what you got wrong, and you have no idea how to go back and study for it, freestyle does let you do exactly that. Also within the freestyle are all the book information. So if you wanted to understand the OSI model, you can click and understand all of the study notes associated with the OSI model. It's all right here. And of course, my videos are integrated with it as well, right into the book. So this is a section in here that talks about peer-to-peer. Well, right in this view,
technologies that they
there you
use
go.
to operate.
You can watch my videos that are
and the
integrated
other
right
one
into
is
the
called-
book. So you don't have to go searching around for the right video at the right time. They're right here in this piece. And one of the nice things they've got going is they've some free samples that you can go out to their website and you can try this out for yourself. So don't just trust what I'm telling you about it. Go out to professormesser.com/freestyle and it will take you to the page where you can get some of these free samples of this. A really nice offering from the folks at GTS Learning. I spent quite a lot of time there. So it's very, very useful to be able to see that and have those pieces there. And we appreciate them absolutely being a sponsor of what we're doing here at Professor Messer. Well, I have questions also that you've sent me this week. I realize we're at the top of the hour. We're 60 minutes in. I do have other questions about the questions. So a lot of you send me questions about the test itself. What should I be looking for on this test? What are the types of things I would expect to see? So one question is this one. What is a good way for a student to get hands-on training with network equipment? George asked this, but it's not like we have a lot of network equipment sitting around our house. George is absolutely right. You know, you don't have a lot of switches. There's not a lot of routers sitting around. You don't have a lot of access points sitting around, but you do have some things you can do. It's interesting, these devices that we have at home, because these home-based wireless access points that we have, these routers that we have a lot of different pieces inside of them. They have routers, and these routers are natting. So if you're plugging into a network connection, this is your internet connection. It's usually colored a different color. This connection is natting everything coming from these other connections on the device. Very, very, very useful to have that functionality. You can start working with NATs and understanding how the natting works. There's also port forwarding that it does. If somebody's inbound, you can effectively do a reverse NAT there, coming to the inside, a destination NAT, and come inside and do some port forwarding to it as well. Very, very useful. These 4 other ports on the device are switched ports. So you can now test on a single subnet multiple devices if you would like to. And there's a whole MAC address table that decides how traffic is forwarded between those. You've also got wireless built into a number of these devices as well. So you've got all the wireless, the WPA, the WPA2. You can test with WEP. So all of the things for a Network Plus certification, the concepts and the functionalities are all contained within these wireless devices, these wireless routers. So for $25, you might have everything that you would need to be able to test your MAC level communication, your routed communication. It doesn't even have to plug into the internet. You could simply plug devices, one device on one side, on the switch side, one device on the routed side that's on the outside, the WAN port that they call it, and watch the natting that occurs between those two. You could set up a whole routed connection here that really is just a smaller version of exactly what they run in very large enterprise environments. It's the same NAT on this device as it is on an enterprise router. It's the same switching that takes place here that takes place on an enterprise switch. Exactly the same. Networking is exactly the same. This is just smaller. And for your home environment, that could be very, very useful to be able to use that and set things up. So you can start to understand, how would we set up WEP? Why is the WEP set up in here in a certain way? Why is that not something I should use? Let's try to crack it. Let's set up WPA2 and see if we can crack that one. So there's different things that we can use just by having this equipment right in our environment and being able to work with it. So if you've got these, take advantage of them. They can be very, very useful to have and to be able to use. Another question is, this came from Reggie, who's in our chat room today. It says, I'm unable to view your videos in Germany due to music restrictions. Can you remove the music, please? And I recognize this very early on my A+ videos. I put music at the beginning and music at the end. And the music is licensed music. I've bought the music. I've paid for this music. I have the rights to use this music. But in Germany, that doesn't matter. And there is as my videos are posted on YouTube, YouTube has an agreement with Germany that if anybody puts their videos out there and they make revenue from those videos, like we do here at Messer Studios, you can't watch them. You can't watch anything with music. And that's why you'll notice my Security Plus, my latest Network Plus, none of them have any intro music and no outro music. So Reggie, I understand. And all of my videos from this point forward will not have music in them because at the very basic part, it doesn't really add much to this. It's not like I'm a band, so you don't have to have music, and it would allow the folks in Germany to watch this. The weird things we do on the internet to allow traffic and to have people watch videos. But I absolutely understand. I recognize this. And in the future, you'll be able to watch every single video. You can watch all of the 005 videos right now. You can watch all of the Security Plus videos, and going forward, you'll be able to see all of them. So that's kind of a weird thing. You don't think about that here in the States. So my friends in Germany, you can absolutely see those videos today. Leela asks, what's the best way to study and understand the material for the exam? And that's one of the questions I get quite a bit is, what's the best way of study? What's the information I should look at? What are things that are most important that I should go to? And I have one primary answer for all of you. If you have not done this, you should do this immediately, and that is to download the exam objectives from CompTIA. The exam objectives are incredibly detailed. CompTIA puts a huge amount of detail into the exam objectives, and they have very specifically written out exactly the things you should know. You should know these parts of the OSI layer. You should know these parts of the TCP/IP model. You should understand how applications, devices, and protocols relate to the OSI layers and how they relate to those OSI layers. So feel free to go through, download this group. It's a huge number of pages. Download all of those pages. I printed mine out on a piece of paper on a dead tree, and I used it as a check mark list. Every time I thought, okay, section 1.1 says compare the layers of the OSI and IP models. OSI model, if I got that one down, I feel like I understand that one, check mark. The TCP/IP model, I feel like I understand that one, check mark. Where does IP address fit in the OSI model? I'm not sure yet. Let me circle that one. Now, to find this, there's no simple link on the CompTIA website. You can go to Google, and you can type in Google the CompTIA exam requirements, and you should be able to get there. But if you just go to the CompTIA.org website, let's bring it up and go through it ourselves. We'll visit CompTIA, and we'll choose exactly what we want to do. At the top of the CompTIA website is a certifications link. We certainly are interested in certifications, most specifically the Network Plus certification. So I'm going to choose the Get Certified that comes up and just find the Network Plus page. That's a good place to go. On the Network Plus page, right here on the right-hand side is a box that says, Get Started Now. See what the exam covers. That's what you want. You want the See What the Exam Covers link. And as it goes in here, you can see now the exam coverage. You put in your name, your email, your country, and it gives you a link to download the exam requirements. So that's what you'll want to do. And once you have that, you'll have that exact exam requirements list that you'll be able to choose from and be able to work with. So make sure that you do that. Make sure you have access to those pieces. Make sure you look through that. It's surprising to me that a lot of people will send me emails or they'll get in touch with me and they'll say, okay, I think I'm going to take my test next week. Is subnetting on it? Well, don't you have the exam requirements? Haven't you looked through what they're going to ask you yet? Oh no, I had no idea these were here. Make sure you take advantage of it. Not all organizations provide you with this level of detail. And to be able to have all of this here, and they stick to it pretty close, and use it as a checkbox and go through it, very, very valuable, very, very useful to have. Use that material. Read through it. Understand exactly what will be asked of you when you walk in the door. And I assure you, once you go through that list, you'll feel a lot better about yourself walking in. I know 90% of what I need to know. I'm ready to go. I'm ready to take this exam, and I know exactly the type of questions that they're going to ask of me. That's exactly what you'll want to do. That will be the valuable part that will get you where you need to go. I have one more thing to share with you. I come across different things during the month, and I think, on my Network Plus group, they would love to see things like this. This isn't anything that necessarily has to do with the Network Plus exam, but it would be very useful to have there. My link of the moment is on Reddit. I love to read Reddit, reddit.com, and there is a subreddit within reddit.com which is /r/cable fail. So if you want to see how not to wire your particular network, this is the subreddit for you. So that's pretty bad cable fail right there. And it has example after example after example. Now, there's also probably a not well named, but there's a cable porn, which is not safe for work. The r/cable porn is actually perfectly done cabling. So if you wanted to see the exact opposite of the cable fail, you can go to the cable porn subreddit, which I assure you has absolutely safe for work images. You will not be surprised when you see that. When you get there, you can actually learn a lot from these as well, because people who are doing cabling reply to this. There are conversations that take place, and they'll tell you, here's what you need to do to resolve this, or here's what we used to make sure all of the cabling worked perfectly for what we were doing. So if you're somebody who's trying to learn and figure this out, there's some real experts on there that can absolutely help you out. And Reddit's just a great site. The link's at the top of the page there, reddit.com/r/cable fail, to be able to see that. Very, very nice to be able to flip through those. And there's a new one, 2 or 3 or 4 every day. It's quite surprising to see those pieces that are there. Well, one last question before we finish up today, which is this one. I want to know from your perspective what you would like to see on the next Network Plus study group. So this is an open-ended question. If you go to pollev.com/messer, and you want to know exactly what's going on, what topic you would like to see on the next Network Plus study group, I'll be able to get your responses in here and understand exactly the types of things you would like to see. Now, what I'm going to do is I have a moderator view on my side, so I'll start adding these, and some of these are really good. We've got cloud technology, subnetting, authentication protocols, virtual networking. These are all absolutely some of the newer pieces that are on the Network Plus exam, especially things like cloud technology and virtualization. Wide area networks, there's absolutely some new things we can go through with WANs. More questions about protocols are coming through. This is the information that I use to build the materials when we do this next month. So a lot of really valuable information coming through. IPv6, another virtualization, VPN, intrusion detection capabilities and intrusion prevention. Specifically, Snort was mentioned, but IDSs and IPSs are certainly an important part of the Network Plus certification. Proxies. If you look at the new Network Plus cert details in the back, there's a huge new section just on security. So those become pretty important. Router protocols are another important one, especially being able to send routes back and forth over your network. So I'll absolutely consider that one. Network Essentials tends to be a pretty important question as well. So I appreciate you sending that one in. Keeps me understanding where I should focus with some of these. Command line usage is also an important piece of the Network Plus. We see that one asked a lot as well. VPNs come up quite a bit. There were a number of VPN questions I just didn't have time to put into the study group this month, but I will be able to do that on the next one. And honeypots are also one that came through. Honeypots are also one of those options that comes in, or things that you're asked of on the Network Plus certification exam. Authentication protocols are as well. There's a huge new section in the back that goes through a lot of security details. If you're going through the Security Plus certification, you're certainly familiar with those as well. Some of these are a little bit off scope of the Network Plus, but this one happened to hit exactly, which was setting up a router. One of the new things on the Network Plus is how do you set up a small home office device? Set it up from beginning to end. What are all the things that you need to configure in there? That becomes useful too. The intrusion detection, IPv6 has come up a lot in these responses that have come in. And IPv6 being a newer technology, not one you see a lot of in the wild. There's a number of people using IPv6 today, but certainly not widespread. So a lot of people want to know more about that piece. And certainly with troubleshooting, being able to see those pieces as well. Subnetting keeps coming in, and I absolutely can appreciate that. We'll absolutely have another subnetting question next time. And there again, another subnetting has come in. I understand. I can appreciate it. Fantastic responses. I appreciate all of you going in and sending some of those things through. Very, very useful to have those there. And for those of you that have been watching our videos online, you know that we are constantly building out more and more of those network videos. I'm currently up to the 4th chapter. There's 5 total domains in Network Plus, and we'll have all of them done for the 005 exam very, very shortly to have those pieces there. So keep that in mind. For those of you that that will be looking for some of these things later, we have all of these recordings saved, and I'll talk more about that once we finish up the main recording today. So for those of you that are looking for what we're doing at Professor Messer, you want to be informed every time we do one of these study group sessions or when we do anything that's interesting, you can follow us on Facebook at professormesser.com/Facebook. Or you want to see the tweets whenever something live is going on, I will tweet it out at professormesser.com/Twitter. I'm trying to do more on Google+, so professormesser.com/Google+. And of course, I have hundreds and hundreds and hundreds and hundreds of videos out on YouTube, which you can find at professormesser.com/YouTube. You see a trend there, don't you? I want to also thank GTS Learning again. Their freestyle course, absolutely amazing. You should go check it out and try it yourself for free. They're great sponsors of what we do here at Professor Messer. You can find that at professormesser.com/freestyle. And of course, thanks to all of you, your questions this month and every month have been invaluable for me to be able to put this together and provide this information out to what you're doing. And I think that as we do another one next month, I'm going to ask for your questions again. You folks are so great about providing me with those pieces and bringing them in. It really, really makes a difference for the study group. Well, with that, I'm James Messer. Thanks again for joining us on the study group, and we'll see you next time on Professor Messer's Network Plus Study Group.